Okay, this video is going to pick up where the last one left off. And so the last one we had cycle colors. And so what we're going to do is we're going to go ahead and double slash it. If you haven't watched the first video, you can either do so, or on this video you should be able to download the code and it will already include all of this stuff typed in. Because some of these things we'll do will require the use of the past stuff we did. Okay, so we double slash out cycle colors, which means that the computer's not going to read it. And we're going to do another one. We're going to write a function called fade in red, open, close, semicolon. And so when you're telling these functions you want them to run, you put an open, close, and then a semicolon. Now down here, outside of the void loop, we're going to write the function void fade in red, open, close. And now because we actually have to type something in there, now we put the curly bracket, hit enter, it automatically generates the second curly bracket. And so this is where we're going to type everything here. And so the thing we want to do is we want to have all the colors start off, and then we want them to slowly increase until the red is at its brightest. And so what we could do if we were to do this the way that is probably the least efficient, we could use the function that we wrote before. So we have this light all pixels function. And the light all pixels, we can type in any color it is that we want, red, green, and blue. And so we're going to use that one. We're going to say light all pixels. And we're going to tell it which one we want to fade in. We're going to tell which colors we want to do. And so let's say, for example, we're going to do this first the way that doesn't work very well. Let's say 0 red, 0 green, 0 blue. Then we're going to say, let's wait a little bit. Let's delay, and the amount we're going to delay is, let's say, 10 milliseconds. And then what we're going to do is we're going to have it increase in value each time. So it starts at 0, now the red value, whoops, I should actually copy the time here. It then increases the red value to 1, and it then increases the red value to 2, and we'll do one more, and it increases the red value to 3. And so this is kind of step by step what we want to do. We want to have the green and blue stay off the whole time. We want the red to be 0, and then 1, then 2, and all the way up to 255. And as you can see, this is going to be really tedious. This is going to take a really long time to do. So in a moment, we're going to delete all this. This is just to get an idea of what's happening. We're going to replace this with a for loop. And so we're going to say for, and there's a number that's going to start at 0, which is the brightness. Then it's going to increase to 1, 2, 3, 4, 5, and it's going to go all the way up to 255. And so 255, I'm going to go back here to my this paper, which is attached to this file here. And if you look on the first page, it talks a little bit about the different types of variables. In the last video, we talked about an integer. That an int can go from around negative 30,000 to positive 30,000. That is way too large because our maximum value is going to be 255 because that's the brightest that red can be. And so we're going to save space on the Arduino by using a byte. And so we're going to work with a variable called I, and that's a byte that's going to be 0, then 1, then 2, then 3 up to 255. And we're going to say we're going to deal with it, and we want this stuff to happen as long as I is less than or equal to 255. And what we're going to do is we're going to take I and we're going to add 1 to it each time. Add plus plus. Okay, we're going to close curly bracket, and now inside here, the code that's going to run where I is 1, then I is 2, and so forth like that. So what we want to do is we want to light all pixels. And we're basically replicating what's below, except that the first number is the one that's 0, then 1, then 2, and so that is where we put I. And then the next thing we're going to have to put, the next thing we're going to have to put is the amount of green, which is nothing, and then the amount of blue, which is nothing, semicolon. And then after it changes it to each value, we want to wait a little bit, and we're going to say delay, and we're just going to say this number 10. So now that we've done that, we can delete all of this stuff here. So make sure you keep your curly brackets. And so you should have something like this. So your whole function for fade in red, which is contained between these big curly brackets, is this here. It's going to make a variable, a tiny little variable called I, and it's going to run this function where it's going to light all pixels. It's going to light the red pixel as first. Oh, excuse me. Sorry. We have to start I as to start at 0. And I'm going to hit Command T to auto format. So we're going to have I start at 0. Then we're going to have I increase by 1, as long as it stays below 255. So first it'll be 0, then 1, then 2, then 3, then 4, then 5. And so let's go ahead and I'm going to run this function. So it's going to tell me that when it's uploading, it's going to be blinking here. And it should start off and then slowly fade in. You can see here it's still uploading. And so when it finishes slowly fading in, eventually it's going to get to the end and recycle where it goes to 0 again. So a couple things we're going to edit back here in our code, just really one or two things, is let's create a variable for our delay time. And I would say our delay of 10 seconds is pretty close to what we want. So we don't really want our delay to be any bigger than 255 milliseconds because that would take way too long. So we're going to use a byte type variable to make a variable called delay time. And we're going to have that be that number 10. And so what we can do now is anywhere we type delay time, it's going to look up here and use this variable. In this case, it only is replacing one number, but it's a good habit to do because sometimes it replaces many numbers. And so if we go ahead and do that, and I'm going to change it now, let's say to 1. Now the amount of time between each color change or each brightness change is going to be only 1 millisecond. So I'm going to go ahead and upload that and pull up my video here. And so it's showing that it's uploading now, and it's very slowly, it's very quickly fading in because there's a short delay time. And if you want it to be even a longer fade, you can change that number. Like you could change this here to be 50 milliseconds. And it's going to compile, check for errors, then it's going to upload. Here we can see it's uploading. Now it should be very slow fading in. Okay, so we've played a little bit with the lights. We get a little bit of the idea of the lights. So what we want to do now is do some of the other functions of the circuit playground. So we're going to go ahead and slash out fade in red. I'm going to save my file in case it crashes and I lose all my work. And so the next one we're going to use, it's going to be called read values. And so this tells it to run the function called read values. At the top I can type void read values, open, close, space, curly. And then inside here, this is where it's going to run the code. And so this circuit playground actually has a lot of sensors on it. And so what we want to do is use those sensors and have this one function where it spits out all the values of the sensors all at once. And so we're going to work on formatting that to make it look good. So the first thing we're going to do here is we're going to type capital serial.print. And then if you put a quotation mark, it's going to print words that you type. And if you don't, it's going to print variables. So we want to have it print L equals and that space, and that is going to be our variable for the, that's going to be our sensor, our light sensor. Close quotes, close parentheses, semicolon. And so basically, since the circuit playground does not have its own screen, we're going to use our computer screen as a virtual screen, which is what the serial monitor is. Next, we're going to say serial.print, and we're going to say the code we have to do to get the reading from the light sensor. So if I come back here, for the paper you can download, to get the reading from the light sensor, we're going to take a look down right here. So that's what we need to type. Circuit playground.light sensor. In fact, let's see if I can just copy that from here. There we go. And so it's circuit playground.light sensor, open, close, and then we have to put, because these two match up, we need to close a parentheses here. Then we need to put a semicolon for the end. And so we're going to upload this and we're going to see how this is really hard to read. So what we're going to do is go ahead and click your upload button here. It's not going to make anything come out on the circuit playground, but once this finishes compiling, we're going to open the virtual screen. And so the way we open the virtual screen is up at the top right, there's a magnifying glass. And there's another way, which is Tools, Serial Monitor. That's the same thing. So I'll click this magnifying glass, and we'll see a bunch of jumble. So it's saying, hopefully it's not crashing, it just keeps going to the right, to the right, to the right. And the reason for that is when we set this up, we didn't have it hit the return button to go to the next line. And that might be why it's crashing on me. We'll find out. So what we need to do right here is, because we would like to hit the return button, you hit LN, and what that's going to do is go to the next line. And so if we go ahead and re-upload here, it's going to finish uploading, and this time I'll click here to look at the serial monitor. I'll click Tools, and I'll go to the serial monitor. And so now we can see that this is the value of the light sensor. And right now I've got my iPhone light shined on it, and so if I put my hand in front of it, it goes down. And I'm not sure if I can get this side by side with the, here we go. So if I put my hand in front, let's say I can just block the light there. If I block the light, the value goes down, and it goes back up. So it looks like if I find that light sensor, which is right here, and I completely cover it up, I can get it pretty close to zero. There, I can get it to zero. And the brightest, I might be able to get above where it is now, but somewhere close to 1,000, almost there. Okay, so that's how that light sensor works. While we're on this, let's see if we can get the serial plotter to work. And so if you look up at the tools at the top, right next to serial monitor, serial plotter, and this is really good for stuff like academic school stuff. So this is going to give you a graph of the values. So I'm just putting my hand in front of it here. And this right here, this baud rate, this you can change if you want. It's not really going to matter so much here. It's just the sampling rate. But for this, it doesn't matter. The Circuit Playground makes it so you have to do a couple less steps. Okay, so we've got that one value, but we want to print out all these values at once. And so what we're going to do is we're going to remove the ln because this is no longer going to be the last line. We're going to go to the next line here, and the next thing we want to have this print out pause and find some of my notes. Okay, so we're going to now put the next thing we'd like to know, which is the speaker, the volume level. So we're going to type serial.print, and we're going to put this. We're going to try to organize these where we want it to go to the right. We're going to have it say one value, go to the right a little bit. And so instead of like putting it into a data spreadsheet, we just want to make a vertical line that puts a kind of a spacer so our eyes can see better. And so in your keyboard, the button above return, the key above return, if you hold shift and hit that, that's kind of the backslash button. It's also below the delete key. You'll get this called a single pipe. It's a vertical line, and it's just a vertical line just so we can see a little bit better. And then we're going to say space S equals, that's going to be sound, equals, quote, close, semicolon. And so basically it's going to say L equals the value. Then it's going to put this single pipe vertical line just so we can space things out. S equals, and now we need to put the value for that. So we're going to say serial.print. And to find that, I'm going to go back to our sheet here, which I do believe I have here. Here we go. So it's this right here. It's the mic sound pressure level, and then you put in an amount of time. So it has to do a sample of the volume. So I'm going to grab all of this here without the semicolon. Okay, and instead of time, we want to put the actual number of milliseconds that we're working with. We're going to say 25. So it's going to take a 25 millisecond sample of how loud things are and give us a value for that. And we got to make sure to close this and then a semicolon. And so that's going to be the volume level. And then there's going to be a couple more things we're going to put in here. We're going to say serial.print. And we're going to do the same thing where we do a single pipe each time. And now this is going to be the X tilt value equals. So now we're going to type in the code that gets the X tilt value, serial.print. And I'll take a look back on this data sheet. And this is Circuit Playground Motion X. And we have to, of course, close this bracket, close this parentheses, semicolon. And then we're going to do the same for Y and Z. And so to get Y and Z, because they're nearly identical, we just replace the X with the Y and then with the Z. I'm going to take those two lines and copy them. So right-click, copy, go down below, right-click, paste, and I would like the capital Y to be the Y value, the Y tilt, and then I'll take that one and I'll paste it, and now we're going to do that for Z. I'm just going to go ahead and leave this still for a second so you can pause it. Okay, and let's see if I've got the value for temperature. Yeah, so let's do the one for temperature also. So I'm going to copy this here. Oops, let me close my. Okay, and the last one is going to be serial.print. And let's call this T for temperature. And I'll close that one. And so this is going to give me the reading for temperature. And although there are capacitive touch sensors on here, we're going to deal with that another time. Because this is the last line, we're going to type ln. And so this ln is going to be really important because it's going to be the line break. It's going to like hit enter, go to the next line, so you can read what's going on. Okay, the very last thing we're going to do is we want these numbers to read out less than lightning speed. So we want to say delay, and we're going to put 100 millisecond delay after each reading, and that's just so we can see them better. That's not required to do. So I'm going to go ahead and upload. And so this should take all those different values and format them nicely in a way that we can easily see and we can see later. And so once it finishes uploading here, at the top right I can click that magnifying glass, the serial monitor. And so this is all our values neatly organized. There's the light sensor, I can change. And if I talk louder, the sound sensor changes. And then you can take it and you can tilt it left and right and forwards and back. And the Z is best described as when it's flat, like it would be on a table, it'd be 10. And if it's tilted any way other than being flat, then it changes numbers there. And then there's the temperature. This one's a little harder to play with because changing the temperature quickly is difficult. So now we've got all these values here. Okay, so let's see here. Yeah. All right, so I think I'm going to go ahead and stop this one here, and in the next one, what we'll do is we'll take some of those values and we'll map them out so we can get some sounds to play and we can get them to change as we tilt the pitch. Okay, thanks so much for watching.